Hello, everybody. Hello, everybody. Welcome to this session. And since our first speaker is here and ready, we already see the PowerPoint slides. I would like to introduce Professor Chiara Dalpos for her presentation from University of Padova. So, Chiara, please.
Yes, thank you. Thank you to the organizers and to the chair of this session for the opportunity of presenting this work, which is a preliminary work which started from a request for a consulting from the Veneto region to the department I'm working in. So the title is Mitigation of Hydrological Risk, Ranking of Areas Prone to Water-Related Hazards by Priority of Intervention. So the PowerPoint is blocked. So the motivation for this topic is that the increase in territory resilience and mitigation of hydrological risks become one of the greatest challenges that our society is facing today. Just because due to climate change, sea level and the occurrence of heavy rainfalls and storm are increasing to unprecedented levels. So this is in turn increasing the frequency and intensity of flooding. So the European Court of Auditors in 2018 estimated that the cost of hydrogeological events across the European Union amounted to 166 billion euros in the period 1980 to 2017, but they have also estimated that the cost of hydrological events will amount to 46 billion euros per year by 2050. So this is a great challenge because floods are causing loss of life, significant economic cost and damage to the natural and environment, including cultural heritage assets. So that's the reason why in recent years, the number of medium to large magnitude flash floods have become twice as great than those recorded in the 80s. So in response to these challenges, in 2007, the EU enacted the Floods Directives, which focuses on the protection and mitigation from flooding and mobilizes support from EU member states in the event of a major emergency. So it also recognized the roles of what we define as civil protection in providing assistance to affected population and improving preparedness and resilience. So the basic idea is that there are stringent budget constraints and lack of financial resources which are affecting, at least in Italy, public administration and governments at local and national levels. So in this respect, the Veneto region has suffered from many flooding events in the past and in recent years. Probably the events that occurred in Venice in November 1966 is the most worldwide known events which shocked the world with the image of the high tides and all of the flooding into the city of Venice. More recently, in 2018, the so-called Vaya storm, which was much more like a hurricane, if you can say so, caused enormous damages to forests. Just think that more than 8 million cubic meters of standing trees.
Chiara, sorry for interruption. You are not changing your slides, right?
No, I'm not changing my slides.
Okay, I do apologize.
Sorry.
Just to make sure. Okay.
No. So
go ahead.
It caused these damages, huge damage.
I understand. Sorry.
To forests, to buildings and infrastructure, impacted protection against landslides, avalanches, and floods as never before. It also had a very bad impact on biodiversity, caused some deaths, And basically, because the hydrolation of the entire communities, it was a mountain area affected at the very beginning for weeks. So that's the reason why in 2019, the Veneto region approved an extension of an existing plan of intervention for a total amount of nearly 4 trillion euros. Nonetheless, the implementation of this master plan requires a clear and informed identification of priorities. So the aim of this contribution is to provide policymakers with tools to inform the design of hydrological risk mitigation strategies and the opportunity to rank top priority areas of intervention just because of this lack of financial resources. So they have a master plan, but they need to decide from which part to start in view of receiving additional fundings. So what we do here is trying to propose an operational framework to address hydrogeological risk and uncertainty through an integrated approach. The idea is that this approach should be easily understood by third parties and applied both to urban, rural areas and also to mountain areas which are exposed to water-related hazards. So as all of us know, the design of this risk mitigation strategy is very complex. There are many stakes and stakes are high. Decisions are very costly to reverse and decision variables are stochastic. In addition, the consequences of the decision taken by policymakers last for a long period and affect different stakeholders whose support is fundamental for policy successful implementation. The point is that these stakeholders may have very different views on the problem and have for sure conflicting objectives. So the process and the problem under investigation involves many actors and calls for consensus. And this is usual in public decision processes which involve a legitimation issue, basically because there's a general mistrust between public opinion experts and policymakers. We are facing social fragmentation when taking public decisions, and there is the opposing interest between short-term agendas, which are usually the agendas of politicians, versus long-term concerns related to the environmental rhetoric and so on. So what we used is, the idea was to adopt a multi-criteria decision method to address these strategic decision problems, thinking that they can contribute to improving accountability, legitimation, and consensus. So basically, we developed and implemented an absolute analytic hierarchy process model to rank top priority areas of intervention. And the basic idea is that we need to mitigate hydrogeological risk. There are many areas prone to water-related hazards, and they need to set a list of priorities to start implementing the plan. So the basic idea is that we wanted to provide a dashboard of weights because the environment is changing very rapidly and many others floods events are occurring. So the basic idea is that we provide a dashboard of weights to account for changes in the evaluation of different alternatives area on single criterion, eventually due to changes in the boundary condition of the decision environment and of the environment itself. So to structure the decision problem and define the hierarchy, first of all, we conducted an extensive literature review, and then we started by interviewing 9 experts. As I told you, this is a preliminary work. So we interviewed academicians in different fields, so geology, hydrology, hydraulics, and also forests. And we also interviewed a few policymakers from the Veneto region who was in charge of the civil protection department for the Veneto region, and we also interviewed some stakeholders in terms of representatives from the society and the business in the business sector. It was not possible to gather the panel because the academicians were international. It was impossible to gather the panel and stakeholder in a single workshop. We involved them, as we did in previous situation, in a Delphi survey process, because usually respondents are familiar with this process, and first of all, it permits us to elicit opinions of respondents who can be geographically dispersed. So each of these 9 experts compiled the entire set, obviously, of pairwise comparison matrices. Then we checked for the consistency index for each matrix, and then we send back the questionnaire for different rounds in case a revision of value judgments was necessary to reduce inconsistency to the acceptability limit. Then we combine expert judgments by calculating the geometric mean, and we finally organized focus groups for brainstormings, specifically with some experts, but as much as stakeholders as we could contacted, and to validate both the hierarchy and the priorities. So we had a dynamic discussion just to try to create consensus on the set of ways. So our hierarchy at this stage was rather simple. So the goal on the top, which is ranking of top priority areas of intervention, then we consider basic economic criteria, environmental criteria, and social criteria. We disaggregated environmental criteria into water quality deterioration, soil erosion, pollution due to contamination, and loss of biodiversity. Social criteria are disaggregated into loss of confidence among population, change in expectation and perceived unsafety, and loss of sense of community. Then, as far as economic criteria are concerned, we consider repair, reconstruction cost of real estate assets, repair, reconstruction cost of infrastructures, loss in regional GDP, cost for temporary relocation of local population, and health and sanitary costs. For each of these criteria, we identified 5 ratings ranging from null, very low, to low, moderate, high, and extreme. Basically, I don't know if you can see the hierarchy where we are not representing because of the lack of space. To share with you very quickly are the local priorities that we identified after finishing the Delphi survey process and after calculating the geometric mean to aggregate the experts' value judgment. And this is what was shared within the members of the focus group. As you can see, environmental criteria and economic criteria, regardless of environmental criteria, are relatively more important than economic criteria, but they are more or less the same relative importance. Let's consider it so far social criteria. Then you can see also the relative importance of any of the sub-criteria considered. So as far as environmental criteria are concerned, soil erosion represent a sub-criteria of major concern. If we look at the social criteria, the change in expectation is the sub-criterion which is as ranked as first. And then, of course, economic criteria, repair and reconstruction cost of infrastructure is what is considered to be the most relevant, followed by the repair reconstruction cost of real estate assets. So here you can have an idea of the relative importance of the ratings, and the we are still in this preliminary phase, so we are still testing these preliminary results in terms of global priorities to some set, to a subset of areas. What I can say so far is that this framework try to address a preliminary and fundamental step in the design of cost-effective hydrogeological risk mitigation strategies, because first of all, they have the need to identify which areas to focus on firstly, and then to better define the intervention already identified at a preliminary stage in the master plan. One of the limitations is that this dashboard of weights has been identified for the Italian context. So we interviewed people, experts with reference to the specific context. We deem that this methodological framework can be applied to solve decision problems involving the resilience of territories. So if we are not thinking about hydrogeological risk mitigation, but other forms of hazards or planning processes, we think it might be useful to adopt an AHP approach. Further development is we have the idea to, in the further step of the research, to better disaggregate the sub-criteria and to find a way to provide a more sophisticated definition of ratings and to better define the algorithms to state the ratings. So also improve the relative measurement scales. That's basically what we hope to do in the near future. So thank you for your attention.
Okay, thank you very much, Chiara, for your presentation. Any question? Is there anybody who would like to contribute or any question? I guess no. Okay. Well, AHP is really commonly used for disaster, post-disaster phase and mitigation processes. So I am sure Chiara also has seen many papers about it. So this is an important.
Initially different methods, but.
Yeah, also the other multi-criteria decision making. We couldn't hear your last words.
I know, I was saying that we initially tried to apply also different methods, but they were too complex to be understood and to provide, let's say that the results of the AHP are more easy to be understood and shared with the stakeholders. So we definitely switched to just to the application of the AHP.
Yeah, I understand.